This is lesson 11-5, and we're going to talk about proportions and how they work when you talk about area of two-dimensional figures. Like these two in front of us here, we have two rectangles. So if we can figure out the ratio of their sides, how does that relate to the ratio of their areas? So let's take a look at two examples. Here I have a smaller rectangle with dimensions 4 by 10. And here I have a rectangle with dimensions 8 by 20. And so we have a few questions to guide us through here. What's the ratio of the sides? So 4 relates to 8. I'm going to write it like a fraction, 4 over 8. I'm going to simplify that. Would be 1 to 2. Now let's ask the question, what is the area of both of the rectangles? Well, the one on the left is 4 times 10, so the area would be equal to 40 square units. And the one on the right, the area would be equal to 8 times 20, which is 160. And so we found the area of both the rectangles. Next, what is the ratio of their areas? The ratio of their areas would be 40 over 160. 40 to 160. If I divide both the numerator and denominator by 10, I get 4 over 16, and if I divide them again by 4, I get 1 to 4. Alright, so this is kind of the groundwork here to help you understand the relationship between the ratio of the sides and the ratio of the areas. So let's just flip over to here. The ratio of the sides is 1 to 2. The ratio of their areas, let's just flip back here real quick. Ratio of this is 1 to 2. Ratio of their areas is 1 to 4. Take a look at this, 1 to 4. The question here says, what do you do to the ratio of the sides to find the ratio of the areas? Well, what you do is you square it. 1 squared is 1, and 2 squared is 4. So anytime you have the ratio of the sides, you square it, and that gives you the ratio of their area. So I have an example problem here to show you how we can use this information in a problem. Two triangles here, and we have this little bit of information right here. And we have this bit of information right here. Alright, and then the base is 3 and this base is 9. Alright, first question to help us answer this is, what is the ratio of the sides? Well, the sides, with the two bases here, the ratio is 3 to 9, which simplifies to 1 to 3. So the next question, what is the ratio of the areas? Well, we are going to apply our new rule. And we are going to say 1/3, and then we're going to square that. 1 squared is 1, 3 squared is 9. Alright, now how can I use that to help me find the area of this triangle here? If I know the area of this triangle is 9. Well, the ratio of their areas is 1 to 9, and the area of the smaller one is right here, 9, and I'm going to call the area of the large one A. Alright, so let's solve for A. 1 times A is A, and 9 times 9 is 81. And that's it. The area of the larger one is 81 square centimeters. So that's how you can put that fact that we just learned in the previous slide into use. Alright, if you have the ratio of the sides of two similar figures, alright, that's x over y. The ratio of their areas is x squared over y squared. Alright, and you know what, the only thing that I didn't mention in my whole problem is does this work for circles? Does it work for circles? And the answer to that question is yes. Alright, and so in a circle then you would use the radii. Alright, the ratio of the radii. Alright, that is the big idea for ratios and proportions with area.